Hello friends, welcome you all. IS with Arihant. Very good afternoon to everyone, and the aspirants who do not subscribe the channel yet, subscribe the channel and share this class. Also hit the bell icon to get the notification on time of every class. So IS with Arihant launches this year a new prelims possible book. So if you do not have this book, so you can purchase this book because this book has really amazing content and good explanation of every single question given in this book. So if you want to qualify or you want to select it in the UPSC or state PCS exam, so you must have this book to understand the basic concepts given in this book, also some bullet points. Now let's check out what the features of this book given here. Prelims possible, now easily possible. Why? Because chapter wise, topic wise division, topical mind map, 100% error free explanation, knowledge plus for typical question, and 3500 PYQs bullets. Let's start our today class. We discussed in the previous class second unit of physics, that is mechanics, right? And in the mechanics chapter we started first topic our motion and Newton's motion of Newton's motions law of motions. Clear? So we already discussed the theory part and we are discussing the questions. Now let's start the question answers today. This question number 12. The velocity ratio of the hour end and minute hand of a clock is 1:12, 12:1, 24:1 and 1:24. So before going to discuss this question, we have to understand what is the question wants. The velocity ratio of the hour end and minute hand. Ratio of this, right? So in this question we have to apply the angular speed formula. Angular speed formula generally computes the distance that is covered by the body in terms of revolution or rotations to the time taken. Angular speed denoted by omega, right? And what is angular speed? Is equal to total distance covered, upon total time taken. Now let's take the velocity of hour and clock is the velocity of hour hand clock is equal to WH, we denoted as WH, and the velocity of minute hand clock is WM. Minute hand clock is WM. Now we are going to put the values in given formulas. First, the time period. First, we have to calculate the time period of hour hand clock per cycle. The time period is equal to hour hand per cycle is 12 hours per cycle is equal to how much? 12 into 60 minutes per cycle. 12 into 60 minutes per cycle, and what it gives? 12 into, it is in, we are going to short this, 12 into 60 into 60 minutes. 12 into 60 minutes into 60 seconds per cycle. Right? Now we have to take the next page, a blank page. Angular velocity of our hand is equal to how much? 2 into pi upon 12 into 60 into 60. That is 2 into 3.14 is the value of pi upon 12 into 60 into 60. Right? Now, we have to calculate the angular velocity of, or before we calculated the angular velocity of minute hand, we have to calculate the time period of minute hand clock. The time period of minute hand clock is equal to per cycle is equal to 60 minutes per cycle is equal to 60 minutes into 60 seconds per cycle. Right? Now we are going to calculate the angular speed of minute hand. Angular velocity of minute hand is equal to 2 into 3.14 upon 60 into 60. All right. Now what we have given? We have given the angular velocity of hour hand upon angular velocity of minute hand is equals to 2 into 3.14 upon 12 into 60 minute into 60 minute into 60 second upon the angular velocity of minute hand 2 into 3.14 upon 60 minute into 60 second. Now cancel out this equation, this cancel out this, and this we reciprocate here, the denominator comes 60 into 60 upon 12 into 60 into 60, that is, this is cancelled out by this, and 1 upon 12. Then what the ratio we will get? 1 is to 12. 1 is to 12. Right? This is our final answer. So here our correct answer is option number A, 1 is to 12. Right? Here comes to the explanation. The velocity ratio of the hour hand and minute hand of a clock is 1 is to 12. The minute hand of a clock covers 360 degree in 60 minutes or 6 degree per minute. The hour hand of a clock covers 360 degree in 12 hours. The minute hand of a clock covers minute hand of a clock covers 360 degree in 60 minutes or 6 degree per minute. right? The hour hand of clock covers 30 degree in 60 minutes or 0.5 degree per minute. The hour hand of clock covers 30 degree in 60 minutes and 0.5 degree per minute, right? So 360 degree upon 12 becomes 30 degree per hour, or 30 by 60 degree per minute is becomes 0.5 degree per minute. Since angular speed and linear speed are related as v is equal to r and omega, that means velocity directly proportional to angular speed, right? Hence, the hour hand upon minute hand is equal to omega angular velocity of hour hand upon angular velocity of minute hand. Here we put the values here. 0.5 is the angular velocity of hour hand and angular velocity of hour hand upon angular velocity of minute hand. 0.5 upon 6 is equal to 1 by 12. So the hour hand ratio minute hand is equal to 1 is to 12, right? Question number 13. A stone tied to a string is whirled in a circular path. As it was revolving, the rope suddenly snaps. Then the stone flies off tangentially. The stone moves radially outward. The stone moves radially inward, or none of the above. What would be your answer here? So when we start the chapter, we must understand Newton's law of motion. They give three laws of motion, and the first one is called as law of inertia. Law of inertia. Again, this law of inertia further divided into three parts. Inertia of rest first, inertia of rest, inertia of motion, and the third one is inertia of direction. So tell me, a stone tied to a string is whirled in a circular path. At it was revolving, the rope suddenly snaps. Then this examples of which law of motion? Inertia of rest, inertia of motion, inertia of direction. So when we studied about inertia of direction and the definition of this, when the resistance is offered by the body to continue the motion in the same direction unless an external force applied, right? So this stone moves or flies off tangentially. Option number A would be the right answer. Answer A. When the stone tied with string whirls in a circular path and a string suddenly snaps, then the stone flies off tangentially in the direction of its instantaneous velocity. Clear? Now comes to the next question, number 14. Projectile motion is a combination of horizontal motion with constant dash and vertical motion with constant dash. Acceleration, velocity, velocity, acceleration, displacement, velocity, or velocity, displacement. How will you define the projectile motion? Projectile motion is the motion of an object thrown or projected into the air subject to only the acceleration of gravity. Only the acceleration of gravity The object is called a projectile and its path is projectile motion. What will be the right answer of this question? Velocity acceleration. The correct answer of this question, option number A. Projectile motion is a combination of horizontal motion with constant velocity and vertical motion with constant acceleration. Projectile motion is a combination of horizontal motion with constant velocity and vertical motion with constant acceleration. When an object is thrown obliquely near the Earth's surface like this, if you want to throw, you can also experiment this projectile motion like this, right? This is the projectile motion and this path called as parabolic path. What is parabolic? Near the Earth's surface, its motion is along a parabolic path and its motion is known as projectile motion. This motion can be considered as combination of two independent one-dimensional motion, which is one along horizontal direction with constant velocity and other along vertical direction under constant acceleration due to gravity, right? Now comes to the next question, number 15. A boat moves forward due to. A boat moves forward due to Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, and Newton's fourth law of motion. So we always studied about Newton's three law of motion. There is no fourth law of motion. There is no need to hear. So a boat moves forward due to. So the right answer is Newton's third law of motion. Why? Because third law of motion says every action has equal and opposite reaction. Equal and opposite direction. If boat moves forward in the water, right? So this is the example of Newton's third law of motion, just like walking on the road. Another example of this Newton's third law of motion, walking on the road. How will you explain this? Newton's third law of motion, the ground exerts, when we are walking on the road, the ground exerts an equal and opposite force on the person, and this reactive force enables the person to move forward, right? Answer C. A boat moves forward in the water due to Newton's third law of motions. Newton's third law of motion states that to every action there is always an equal and opposite reaction. Thus, when the boat pushes the water backward, action, this is the action. When the boat pushes the water backward, this is the action, and what will be its reaction? With a force, this water pushes the boat forward, this would be the reaction with the same force, hence a boat moves forward. This is the right explanation of the question number 15. Now comes to the question number 16. As the train starts moving, the head of the passengers sitting inside leans backward because of inertia of rest, inertia of motion, moment of inertia, or conservation of mass. You also study one of the example of the train. When a train suddenly starts it moving forward, the passenger standing in the compartment tends to fall backwards, right? Now that example belongs to which law of inertia? Inertia of rest, inertia of motion, moment of inertia, conservation of mass. Tell me, what is this right answer of question number 16? So both the examples are related to inertia of rest. when you are standing in the bus, when you are standing in the compartment of the train, right, and train moving forwards, right, bus moving forward, but your body, your upper part, you divided your body upper part and lower part. Lower part is moving towards the bus, but the upper part of the body is at rest, which deny to apply force on it. That is why if any particle or any body wants to or in a rest position, it deny or resist the motion or force, external force applying on it, right? So this is the best example of inertia of rest. As the train starts moving, the head of the passenger sitting inside it leans backward because of inertia of rest. From the Newton's first law of motion, an object which is initially at rest will be continue to do so unless an external force acts on it. Hence, when the train starts moving, the man is still at rest and hence appears to move backwards with respect to the train. This is called inertia of rest, right? Comes to the next question. Question number 17. Newton's first law of motion is known as gravity, law of inertia, law of conservation of momentum, vertical motion. So we are acknowledge this point that Newton's first law of motion, everybody knows that Newton's first law of motion also known as law of inertia. So option number B will be the right answer. Newton's first law of motion, what says? It says if any body or any particle is in the state of rest or in the motion, it denies or resists applying external force on it, right? And there are also 3 laws of inertia. And what will be our at rest? Inertia of rest, inertia of motion, inertia of direction. Newton's first law of motion is known as law of inertia. It is called the law of inertia because it tells that every material has a property by virtue of which it resists the change in its state of rest or in its state of motion, right? Question number 18. An oil tanker is partially filled with oil and moves forward on a level road with uniform acceleration. The free surface of oil then remains horizontal, is inclined due to the horizontal with smaller depth at the rear end, is inclined to the horizontal with larger depth at the rear end, and assumes parabolic curve. What will be the right answer of this question? According, the rate change of velocity is called the acceleration of body. According to, or we must say it is acceleration. First we discuss the acceleration. The rate change of velocity is called the acceleration body. That is acceleration is equal to v2 minus v1 upon t2 minus t1, right? And acceleration is a vector quantity. That means it has both direction and magnitude. Also, the unit of acceleration is meter per second square, right? Now, the right answer will be is inclined to the horizontal with larger depth at the rear end. Why? Because so, as if we know that if liquid is accelerated horizontally like this, if any liquid, this is the tanker, any liquid, accelerated horizontally, then the 2 points in the same horizontal line cannot have equal pressure. Cannot have equal pressure, and the oil tanker partially filled with oil moves forward on a level road with uniform acceleration, then free surface of oil is inclined to the horizontal with larger depth at the rear end due to do not have equal pressure. Don't have equal pressure, right? Now comes to the question number 19. Which physical quantity is represented by the ratio of momentum and velocity of the body? Velocity, acceleration, mass, force. Which will be the right answer? Okay. If everybody, any of the aspirants preparing for the UPSC and state prelims exams, so all these are questions we are doing here. It's from this Prelim Possible book by Arihant. So if you do not have this book right now, you must purchase this book, because this book really have amazing content, a good quality of questions, previous year questions, a very important bullet points are given here, and also you can understand many chapters in an easy way, right? So physical quantity is represented by the ratio of momentum and velocity of the body by, what is momentum? Denoted by P is equal to mass into velocity by V. Right? And what is mass? Mass is equal to momentum upon velocity. And velocity of the body, which will be the right answer. So here your right answer is mass. Option number C will be the right answer. Momentum is defined as the product of mass and velocity, where momentum denoted as P is equal to mass into velocity. Mass will be momentum upon velocity. Hence, mass can be represented by the ratio of momentum and velocity of the body, right? Now, comes to the next question, number 20. A bus is moving along a straight path and takes a sharp turn to the right side. Suddenly, the passenger sitting in the bus will be. First of all, you have to answer this example. This is the example of which law? Which Newton's law? Newton's first law of motion, Newton's second law of motion, Newton's third law of motion. So, when we are talking about the bus is moving along a straight path, so this is the example of Newton's first law of motion. First law of motion, also called as law of inertia. And as we know, inertia is of three types. So, from law of inertia, which is three types, so this example belongs to which type of inertia? Inertia of rest, inertia of direction, inertia of motion. So this example is by inertia at rest. Inertia of rest. Right? So the passenger will be bent toward left side. Option number B will be the right answer. When the resistance is offered by the body to continue in the state of rest unless an external force acts on it. Again, when the passenger sitting in the bus, its lower part is with the moving bus, but the upper part is almost at rest and resist the external force applying on it, right? Option B, When a bus moving along a straight path takes a sharp turn to the right suddenly, then passengers sitting in the bus bend towards left side. Initially, the passenger and the bus both are moving in the same direction. When the bus suddenly takes a right turn, the lower portion of a passengers who are in contact with the bus tends to move in that direction, but upper portion of the passengers will be thrown towards the left due to inertia. Right? Now comes to the next question. A goalkeeper in a game of the football pulls his hands backwards after holding the ball short at the goal. This enables the goalkeeper to exert large force on the ball, increase the force extended by the ball on hands, decrease the rate of change of momentum, more than one of the above or none of the above. Which will be the right option you are given here? Okay, by extending the period of time. If a goalkeeper pulls his hands backward, what he's actually doing, he is extending the period of time. Extending the period of time. Why? To decrease the force rate of change of moment. To decrease the force of change in momentum, right, that football exerts on him. And this is because of second law of motion by Newton. All of this because of Newton's second law of motion. So by second laws of motion, according to second rule of motion, a body's force is equal to the product of its mass and acceleration. Equal to the, see, second law of motion is F is equal to ma, mass into acceleration. So force having the equal to the product of its mass and acceleration, right? This is the second law of motion. The rate at which momentum change is the same as force. If rate of momentum changes is at same as force. Why? Because this is the equal product of force, mass and acceleration. Force is defined as mass times acceleration for a constant mass. Clear? So the right answer will be here. It decreases the rate of change of momentum. Option number C will be the right answer. Now comes to the explanation. A goalkeeper in game of the football pulls his hand backward after holding the ball short at the goal. This enables the goalkeeper to decrease the rate of change of momentum. According to Newton's second law, which is F is equal to m, and which is F is equal to m into a mass into acceleration. Here v minus u by t. What is this? This is acceleration. And what is acceleration? Is equal to final velocity minus initial velocity upon time taken. This is the acceleration formula which we are putting here. And what is the rate of change in momentum, and also called as rated change in momentum. So by pulling his hands backwards, the goalkeeper increases time to hold the ball. By increasing the time, he decreases the force, the rate of the change of momentum applied by the football on him. Now comes to the next question. Question number 22. Assertion and reason questions are here. Assertion says a man standing on a completely frictionless surface can propel himself while whistling. Right? Reason: if no external force acts on a system, its momentum cannot change. Is it true assertion is true or a reason is true, and also a correct explanation of assertion. You must understand the assertion, and after this understand the reason given for the assertion here, and then you have to answer this question. So here both A, assertion, and reason are correct here, right? But the R is a correct explanation of assertion. You must say no. Why? Reason is correct because if no external force acts on a system, its momentum cannot change, which is true. It follows Newton's first law of motion, right? Because it is explained by the, or we have to say momentum cannot change. It is explained by the conservation of momentum. Conservation of momentum. Right. So this is the right reason, but not the correct explanation of assertion. Whether we have to talking about assertion is a correct or wrong. So it is also correct. Why? Because a man is standing on a completely frictionless surface can propel himself by whistling. This is the correct assertion. So option number B will be the right answer. Both A and R true, but R is not correct explanation of A. First statement involves the use of Newton's third law of motion. Every action has its equal and opposite reaction. So for every action there is an equal and opposite reaction. In first case, while whistling, a man uses his breath as a propellant, right, to propel himself. The second statement can be explained on the basis of law of conservation of linear momentum, according to which if no external force acts on it, then its momentum cannot change. Clear? Next question, question number 23. For every action there is an equal and opposite reaction. The law was given by. So we studied all the laws given in this chapter in the unit of second mechanics. It is what? Newton's three law of motions, right? So every action has equal and opposite reaction. This is the third law of motion which is given by Newton. Albert Einstein, what it gave? They gave photoelectric effect. Photoelectric effect. Bohr giving atomic model. Right? Option number A will be the right answer. According to Newton's third law of motion, for every action there is an equal and opposite reaction. The action and reaction force always act on different object. The Newton's third law signifies a particular symmetry in nature, that forces always occurs in a pairs, and one body cannot exert a force on another body without experiencing a force itself. Right? Now comes to the next question, question number 24. Which of the following statements with reference to uniform linear motion and uniform circular motion are true? First of all, you have to understand what is linear motion, what is uniform linear motion and uniform circular motion. After that, you can answer this question. Given all the statements, you have to understand which statement is true or false. See, when we are talking about uniform circular motion, a body moving in a circular motion, a body moving in a circular motion, the speed attained by the object will remain constant. So here speed will remain constant, right? Not the velocity, and velocity not constant. As velocity depends on the direction of motion, because velocity depends upon direction of motion, and in the circular motion, the direction of the object changes at every point. In a circular motion, the direction of object changes at every point. A speed remains constant. A speed remains constant. The acceleration will remain constant, right? So when speed is constant, so the acceleration also constant. There is no variation and no change. So first statement, in a uniform linear motion, a body moves in the same direction with a constant speed, but in uniform circular motion, the speed of the body remains constant and the direction of the motion changes continuously. It is the correct statement, right? This one is the right statement. Second statement says, in a uniform linear motion, here is an instantaneous change in the velocity, but in uniform circular motion, the velocity remains the same. It is true or not? When we are talking about uniform linear motion, the direction of motion is fixed. The direction of motion fixed. Why? Because it's a linear, in a straight line. And since it also has a constant speed, uniform linear motion. Constant speed, uniform linear motion does not have constant acceleration, right? Not constant acceleration, but in the circular motion, uniform circular motion, we have constant speed, constant acceleration, but not constant velocity. But in the uniform linear motion, we have constant speed and not constant acceleration. So there's a difference between uniform linear motion and uniform circular motion, right? In a uniform circular motion, the direction of motion changes continuously, but here in the uniform linear motion, the direction is fixed. It is not continuously changed. So the second point is wrong. And a uniform linear motion is an accelerated motion, but a uniform circular motion is not an accelerated motion. Both is not accelerated motion. Both are both lines are contradicted. Only first is the right answer. Option number C will be the right answer. Now check out the explanation. Answer C, statement 1 is true, whereas statements second and third are false. In uniform linear motion, body travels equal distances in equal intervals of time, hence its speed remains constant. We talked about it, right? It is not an accelerated motion. In uniform circular motion, the speed of the body remains constant and the direction of the motion changes continuously. As I told you before this explanation, I told you everything about this uniform linear motion and uniform circular motion. What are they? Thus, uniform circular motion, velocity changes continuously due to change in its direction. Hence, due to change in the velocity, an acceleration acts on the body towards the center of circular path called centripetal acceleration. We have to study this centripetal force, centrifugal force in the next chapter, right? Or in the next topic. So this is the correct explanation of this question. Now, next question 25. A man jumped at a speed of 5 meters per second from a stationary boat and the boat moved off with the speed of 0.5 meters per second. How many times is the mass of the boat greater than that of the man? Now, let's discuss this question. We have to solve this question. So what we have given in the question, given that first speed of man is equal to 5 meter per second, and speed of boat given in the question is 0.5 meter per second, right? Let us consider the mass of a man is equal to m1 and a mass of boat is m2, right? Now according to momentum conservation or conservation of momentum, what we have, m into 5 minus m1 into 5 minus m2 into 0.5 is equal to 0. This is our first equation, and now we are going to solve this equation. That means m1 into 5 minus m2 into 0.5, right? So now what we have take, m1 upon m2. m1 is the mass of man and the m2 is the mass of boat, right? So 0.5 upon 5. This point, let's remove this point from here. We take it here as a 0. Now cut this, cancel out both are these, 1 upon 10. What we get? 1 upon 10. So 1 is the mass of man and m2 is the mass of boat, right? So we can say that mass of the boat is the 10 times greater than mass of the man. So the right answer will be option number D, 10 times. Clear? I hope you understand this numerical part of this chapter. I try to explain you in a very easy manner, right? So there are many methods you can use, easy way or a complicated way. There are so many, or you can also use the short tricks in this. Answer D is the right answer. Let the mass of the man is m1 and mass of the boat is m2. Before man's jump, this is the initial velocity 0. This is the initial velocity of 0, man's jump, right? And velocity is 0. Boat ki, if we are talking about boat, the initial velocity of u2 is the boat is 0. After man's jump, speed of man v1 5 meter per second, speed of boat v2 0.5 meter per second. According to the conservation of linear momentum, as I told you before this explanation, total momentum before jumping is equal to total momentum after jumping. If you want to solve this question by writing all these, this is nothing, only the time waste. If you are sitting in the exam hall and you want to do and you have only 1 or 2 minutes for solving this question, you no need to this type of lines to write there. All right, you can use the shortest way to solve your question or numerical part. m1 v1 plus m2 u2 is the total momentum before jumping is equal to m1 v1 plus m2 v2 is the total momentum after jumping, right? m1 is equal to u. Why? Because the initial velocity is 0. m2 into 0 because the initial velocity of boat is 0. m1 v1 plus m2 v2. So this is the value, v1 5 and u2 is 0.5. So you can also solve this numerical by this method only, or as I told you before, by this only, right? Thus the mass of the boat is 10 times more than of the man. Clear? Now, so this is the second unit of the this is the second topic, force and types of force. So from today class, I think this is enough for the today class. Numerical portion is finished. Now, from the tomorrow class, we are going to start new topic, force and types of forces, right? Force and types of forces. So, I hope you understand the numerical portion in this chapter, and if you are not purchased this book yet, you have to purchase this book to boost your preparation for UPSC prelims and state PCS exams. So you really must have, I really recommended this book because this book really having a good content, a quality of content you have to in this book, right? Also, other subjects having, they included Indian history, geography, Indian geography, world geography, Indian polity, Indian economy, general science, prelim possible series with IAS Arihant. Clear? So thank you so much for today's class.